This video is for Chapter 11, Section 5, and it's all about the volume of pyramids and cones. We've looked at prisms and cylinders and found surface area and volume. We've looked at pyramids and cones and found surface area. It's now time to look at the volume for pyramids and cones. The volume formulas for pyramids and cones are actually pretty simple, and they're connected to the volume of prisms and cylinders because they have the same base. But instead of coming up parallel to another base, we're coming to a point, which means the volume is getting smaller. It's being reduced down. And we're not going to go into the derivation, although it's very cool. And sometime in class, we might use pyramids and spheres to sort of show how this all works. But rather, here's our formula. The volume is actually 1/3 area of base times height. If this was turned into a prism, box on the bottom, square box top, it would have base times height, area of base times height. This pyramid turns out to only be 1/3 of that. So the volume is 1/3 area of base times height. Now we've learned by now that cones and pyramids are exactly the same, except for that the base is pi r squared. So this just becomes 1/3 pi r squared times height. And these are the two formulas we need written down for volume of pyramids and cones. 1/3 area of base times height, 1/3 pi r squared times height. Now, I will point out that in neither of these pictures do I have the slant height identified. 2 videos ago, I talked about the Pythagorean theorems that show up in these cones and pyramids. Here they are on this slide so that you can get it, maybe write them down again or get a real good feel for them. 1. In a pyramid, from center to the center of the side is the apothem. Apothem squared plus height squared equals slant height squared. We have seen this before. In a cone, the apothem has been changed into the radius. Radius squared plus height squared equals slant height squared. If we ever need to use these, we want to be able to identify those right triangles and use the Pythagorean theorem. On a very advanced level, we might run into this one, which is this edge over here. And some students have noticed that if I cut the side length in half, right there, half of the side squared plus the slant height squared equals the edge squared. This is rarely used, but it can be found if we happen to have the edge of a pyramid rather than the slant height. So, something that some of us can write down and be prepared for. Let's take a look at a couple quick examples and be done. So, let's find the exact volume of these two figures here. I have a cone. And the first thing is, what is the volume formula? Well, the volume formula for this is 1/3 pi r squared times height. Right away we should think of something. Wait a minute. I don't know what the height is. I know that the radius is 5 and the slant height is 13. I don't know the height. 1/3 area of base times height. I can do pi r squared times, I don't know the height. So I'm going to use that Pythagorean relationship where the radius squared 5 plus the height squared equals slant height squared. We've seen this one before. 5 squared plus 8 squared equals 13 squared. You do the math there and you get h equals 12. This is 169 minus 25. You can do that work and find h equals 12. Now that I have that information, I can now just say volume equals 1/3 pi r squared times height. 1/3 pi times 5 squared times 12. I noticed that 1/3 and 12 can reduce each other. 1/3 of 12 is 4. 5 squared is 25. 25 times 4 is 100. For a final answer of 100 pi meters cubed. We're doing cubic units because it's volume. Okay, let's look at the hexagon pyramid. Again, we're back to that hexagon pyramid, which is the really tough case for us. So I have a slant height of 6 rad 7, which really is not exciting to me because to find volume, I need the real height, not the slant height. And I have a side length of 12. I got to find a way to understand that a side length of 12 means half is 6, and the apothem, so I'm looking at just this base hexagon here. If the side length is 12, the apothem is 6 radical 3. That's this length right here. And then we can draw a length straight up, and that will be the height that we're looking for. That's going to create a right triangle for us in which we have 6 radical 3, 6 radical 7, and a height. Now, 6 radical 3 squared is really 6 squared, 36, times 3, 108. 6 radical 7 squared is 36 times 7, 252. Subtract 108 from both sides, we get 8 squared equals 144, which we know to be 12. So, we have now figured out the height is 12. All right, well that's great. I'll put the H there, but I still don't have the capital B. I need to find the area of this hexagon. But I know that formula. 1/2 apothem times side times number of sides. Apothem is 6 rad 3, 12 sides. 12 is the side length, 6 sides. So that becomes 216. 6 times 12 times 6 divided by 2. 216 radical 3. There's your capital B. Here's your H. Let's put it together. 1/3 of 216 times radical 3 times 12. Again, the 1/3 and the 12 will reduce to a 4. And 4 times 216 becomes 864 radical 3 meters cubed. This represents, again, the exact area. The key here was to notice it's all about finding the parts. Area of base, finding the height. If the height is given, great. If not, use the Pythagorean theorem. That's it for Chapter 11, Section 5, and we can begin that assignment.